I tried to make this presentation as not too technical, but more about like introduction of I don't know, the topic and the challenges and stuff. So anyhow, let's go to the back to basics, let's say. I just wanted to say that this unsustainable future that is happening to us is really, how to say, terrible. I mean, terrible in terms of using resources and all this globalization taking place and all these things that are so much available to us that we all, I mean, the people intend to misuse it somehow, which also, when we come to plastics, we will talk more about it, but just wanted to show how quick and vast we are growing, and the technological development is growing, and the globalization is there. So this is basically like the small intro. So when we talk about plastic production, Anja mentioned about over 300 million ton letno plastike proizvedemo. So this is where you can see how much it actually increases from the 50s to 2015. That's this graph, but it's really, really significantly increased. So we are talking about over 350 million tons of plastic. So it's really, really, really high production. We use it everywhere, and we really need to figure out to really improve the current situation when it comes to waste and end of use part, of course. So this is just, I wanted to show you that this projection shows where we will go and what will happen by 2030. This is the projection. It's not it's based on, I guess, facts and the plans of the various producers. So we might even for 40% more increase the plastic production by 2030, which is not so far. So this is the projection, but still, I guess the source is relevant, is this WWF, World Wildlife Fund. So we really need, I just wanted to show this in the beginning, to really consider much better actions in terms of waste recycling and plastic recycling and so on. And I think this Econil and Tina's presentation was really amazing, and I will discuss in more details when we come to certain challenges and points where they are really good and what is the problem also maybe for the rest. But there is a need for stepping up the game. So I just wanted to emphasize that this single use and throwaway planet that we sometimes can say that we are living in, I mean, sometimes really misuse things that we produce and that are available to us. So we mentioned this global annual production and consumption steadily increasing. You saw 40% further increase until 2030. So we find plastics everywhere, in packaging, textiles, hardware, consumer products, everywhere. Why? Because they, synthetic polymers are such, they are really low cost and offer really solid performance when you look at how they are made and what they can do. So basically they're low density, they're light, they're durable, they have good processing capabilities, they have good corrosion resistance. So that's why they're in so much use, let's say. And because of the low cost, it's too much available, let's say. So what we do as people, we tend to use too many maybe plastic packagings, and many of it we eventually discard only after one use. So that's the single use issues and all these new legal arrangements to somehow stop this negative trend. But anyhow, you saw the projections, there are high demands for plastic across the supply chain. So also automotive, agriculture, building, construction, textile, medical industry even. So this is also good when you look at the recycling option and about the market for this secondary material, so the waste plastic, let's say. So we will talk about it, and also what's important with this material, as also Tina mentioned, we can generalize it even for this, let's say, plastics. They are all potentially recyclable. I mean, they can be recyclable, it's chemically recyclable, definitely, but I will tell you all the challenges that they are there. So it's not so easy. Theoretically, it's perfect, but in practice, I will present a bit why it's not so easy. And of course, this recycling is limited. I will show you why. You cannot sometimes do it really forever. And you have to always think about this collection part, which is always a mixed material. And there is also a problem in collecting, having the resources needed to, for instance, some production plants that intend to use it. And also you have to provide some economic incentives for also the market and for the economy and for the producers, and also later on for the consumption part and for the people like us. Why should we, let's say, invest more money in buying a product which is, let's say, made with recycled content of, let's say, 100% in an ideal case scenario? So there are many limiting factors, and we will just present it, but I just want to kind of also emphasize in the introduction that we are kind of a throwaway planet, and consumerism is really high right now. So I mentioned that there are lots of sectors that use and produce plastic. So I just wanted to show the packaging sector as really going up front, leading the game. But then we have this building and construction, textiles, other sectors, and so on, even transportation, electronics. So everyone more or less are using plastics. So now when we talk about the challenges, a part of this growing, steadily growing, and all the efforts in reducing this need and growth, it's not yet there. Majority of plastics are never recovered that are in use by now. It's over 85% are not recovered, reused, recycled by any means. So as we say that this increase will be even more, like 40% until 2030, and there is another estimate by 2050 that the waste production in general is expected to increase by 70%. So for me, it's really like high numbers. And so definitely I will mention the circular economy, as also Tina mentioned as well. I try to put kružni model, and definitely I think this need for a shift is here, and it's really necessary, but it's not really happening fast. And we need the investments urgently to support and scale these transformational technologies as ECONYL, for example. So I always say, like, think globally, act locally, but there is this collection issue always present. So many countries, regions, whatever, do not have the recycling infrastructure adequate to properly collect, to sort, to process, and later on market such recycled secondary material. So maybe you're good when it comes to Slovenia, but I guess lots of improvements are there also still to be made. And when it comes to manufacturers, sometimes they are challenged to use these recycled plastics because existing processes that they might have in their factories sometimes are limiting the content, let's say recycled content, if at all it is possible, without some investments or changes in the process. And sometimes this secondary material, this recycled plastics, that we talk about, that is sometimes not performing as virgin material does. Of course, depends on the method of recycling. I will go more about it later. But anyhow, this degradation and contamination takes place. So basically, we need this bold shift in the current approach for us to be able to this high, let's say, increase to hold a bit. So this mismanagement of plastic waste will worsen if we don't really act more active from today, let's say. And we are losing a lot of valuable materials. We are missing opportunities to recover and harvest this value of waste, which, for instance, ECONYL is really doing. But as you saw, as you listened, I listened to the film. I like the film very much. The director, I don't know if it's the director or the owner, said that if he knew what kind of difficulties there are in this process, he might not even start it. So basically, there are a lot of difficulties, but this is what we need, this radical shift in land and this push. And he was really visionary and made it happen. So I really liked this example. So thank you all for providing it. So now again, back to basics. I just wanted to, because we have now to explain, I wanted to explain a little bit more about the recycling of the synthetic polymers. So one of you, maybe Anya, mentioned that there are like some key ones. So I will talk about these plastic big five, sometimes they call it. So these like key ones that everyone knows about, like polypropylene, like yogurt containers, lids, polyethylene. So you have low density or high density, depends if it's like, you know, light or high. And so for instance, plastic bags are low density polyethylene, or high density would be like detergent bottles, for example. Then we have polyvinyl chloride, water pipes, medical equipment, so on. This chlorine there is kind of a problematic, but it's still very much in use because it's really have good properties. So that's with plastic. They are really offering a good options to do them. So then to deal with them, to utilize them. And then we have, of course, PET, polyethylene terephthalate, or these are the plastic bottles, these transparent bottles we use for water, soft drinks, and whatsoever. So why this big five? Because they make up around 70% of all manufactured plastic worldwide. So now when we have to kind of try to explain all the processes, it's better sometimes to target the majority of these main ones, let's say. So basically, when you look at the recycling, you have, let's say, two key divisions, let's say mechanical and chemical. So for instance, Tina mentioned the chemical recycling, we will talk about it, but just first I thought to start with this mechanical recycling of polymers. So basically, this is the plastic waste being collected. So you have to, of course, sort it. There are many ways how good it is to sort, because it's really hard when you have the old mix and dirty components collected to adequately sort it. So I will show some of the examples how you can sort it. Then you grind it basically. Then, of course, wash it up. And then grind it again on the thinner, the separate components, for instance, in order to have the flakes in the end. Why? Because it's easier then to transport, to sell, to be used in other different industries. So this is like a general basic steps of mechanical recycling. For instance, I was talking about this post-consumer plastic waste, which might be, I don't know, dirty, combined, and so on. So there are lots of innovative, let's say, ideas how to basically adequately sort it. So this was one that I wanted just to show. There is also a film. I didn't think to show it now, but you have the link there and all the links to for instance, this technology. So I just wanted to show, for instance, that you need to really think about this separation. So first, the problem is collection, and to have the clean components, which is not easy. And then when you collect, let's say, then you need to really wash it thoroughly to separate it and so on. So this is one option how you separate it, is with the magnetic density separator. This MDS stands for this magnetic density. So for instance, this process targeted this polyolefin waste. So this is basically what you see in the picture, this big five, more or less, as I can say. So as I presented earlier. So basically, after this shredding part, if you remember, and this cutting and mixing, here there is some prototype that they thought of. There are ferrous liquid and a magnet placed above it. And because there is some waste, I don't know, air stream inside and this magnet, then somehow they made that's a kind of innovation, so that on the different, let's say, places, the different materials are positioned. So for them, it's then easier with this floating at different locations, as they mentioned, to be able to easier separate. So you will see more details on the link or in the film. So for instance, just one example how you can magnetically separate. So this is another process. For example, this is developed by Suez. This is really a huge company. I think they're based in France. So this was called quality circular polymers. So basically they're part of this shredding, pre-washing, wet grinding. So it's first grinding part. Then you have to wash it again. That then centrifuges are these air streams that you have to, and this is also separated with like wind. So you have to separate again the different components. then these flakes that you get after all this, like cutting and shredding, you are sorting it by colors, and then homogenize later different components, and then again some filtration, compounding, and so on. So basically, I just wanted to show it's maybe simple process, but not so much simple when you go to the factory and look at this mechanical recycling. And of course, there are some limits. For example, you have lots of times multi-layer products. So it's not one material, so it's mixture of different materials. So this is hard to separate. And why I'm talking so much about the separation, because if you want to reuse again some components, you often as an industry want to know what you are buying, let's say. So you want to know, let's say, if it's one or what is the origin or what is the components of this raw waste stream. So that's why always you need to sort it as best as possible so you can better sell it with a higher price. So then this discoloration of plastic sometimes takes place because you have always a mixture of different colors, and in the end you can very hard sometimes get something, let's say, transparent again. Depends on the, but for the mechanical recycling, definitely there is some food contact that contaminates, and some other forbidden substances sometimes come in, and you are not sure how much are they in the process and so on. So basically, this degradation also takes place. This is also important to mention. So this thermomechanical degradation because of all this reprocessing. And sometimes because you have these mixed polymers in the mixture. And why you have it? Because that's how your inner collected waste is, mixture of everything. This mixed polymers this mixture leads inevitably to the formation of polymer blends. So sometimes they make some components or blends which you maybe don't need or you don't like it to be there. And sometimes in the end, when you put it in the final product, it compromises the mechanical properties of certain products that you try to make. So that's why sometimes if you look at what's the percentage of recycled content in some of the products, it's not easy to reach 100% because you need to maintain the mechanical properties and not to compromise it by lots of inputs which you sometimes cannot control. So this is some of the limits. And I just wanted to show there are many examples of creativity innovation. I will show some other pictures later, but we are here having some students, I hope, and then they can look at some good examples. For instance, here there are young people. They made a startup. So what they did a 3D printing, and now basically they managed to find a way to use some of the recycled plastics to put it back, let's say, in this kind of a material that you do a 3D printing from. And then somehow they did a lot of, let's say, investigations and stuff and made it without sacrificing the final quality. So this is what I was mentioning. They had to figure out the mixture, let's say, and the content in order to get the quality result in the end. So these are young people and they made it happen. So I thought, why not give this example? So they are founders of the startup. And that was like mechanical recycling. Now we have chemical recycling of polymers. For instance, Econil is doing a chemical recycling of nylon, for instance. So basically, there was mentioned the monomers and stuff. So this is basically chemical recycling, means chemical degradation of polymers. So there are lots of monomers connected in the chains. So basically with the chemicals, you degrade it and make it produce again these monomers or other basic chemicals. I will show some of the examples. So what you actually do, there are different ways how you do it. Hydrolysis, so you do it with some kind of water and stuff. Pyrolysis with some like energy, and hydrocracking, gasification stuff. So basically, in the end, you're trying to get new plastics. So you can, with this polymerization later on, you can get new plastic products, or you can produce some other chemicals or alternative fuels and stuff. So sometimes you get back to the original product, or you can use it for the material for some other polymer products. The thing with polymers is that you can, let's say, interfere, they're synthetical, so you can in laboratory, let's say, you can interfere with their composition and make it, let's say, better or stronger or harder, or with combining with some other polymers. For example, I will explain some of the, I will provide some examples. But there are challenges to this chemical recycling as well. So often it's high investments needed because you have to first, collect it again, but then purify it, clear, and then use lots of like virgin materials or I don't know, alcohols or whatever different things that you're using to make it, let's say, work. And then high energy consumption is often needed for all this chemical processes, let's say. So often high input levels are there, and sometimes only large plants economically can be viable. But theoretically, everything is really perfect, but sometimes you need to make this economical, let's say, structure to build it. So basically, these are some of the challenges. So even someone from some, I was giving lots of examples from the producers in this plastic field. So for instance, one CEO of Carbio says the plastic is still fantastic, but end of life, this kind of end of the day, end of life of plastics has not been thought through enough. So basically we need to figure out what to do in the end. So these are one of the examples as well. So what are some other company? I was trying to provide lots of examples. So this is Pyrowave, testing how microwaves are used to break down polystyrene, for instance, into styrene. So one example of a chemical recycling. So basically this is, I just wanted to explain what can be chemical recycling. One of these is depolymerization, this decomposition. So that's what we were talking about previously, breaking molecular bonds to recover monomers. But also there is some, I don't know, purification methods. That's when you're dissolving plastics in solvents, and then you're, let's say, purifying it that way, like cleaning up some remainings that you don't need. And then there is a conversion again, this thermal depolymerization and cracking. This we were mentioning on the last slide, pyrolysis, gasification, and then breaking some additional molecular bonds in order to make a conversion from one waste product to another. So this is another example. What we did on my faculty, I did a PhD on different things in the end, but we try to make as many good materials, useful materials from waste streams. So lots of waste streams we used and tested to make some new materials. So from PET, we were making through some chemical recycling with some certain alcohols that we tried testing it and making plasticizers. So basically, I don't want to talk too much about the chemistry and stuff, but why plasticizers? When you put it in some kind of composite, like some material made of various other materials. So in order to make it more processable, you need to add plasticizers to make it more easy to for manipulation, for making certain products and stuff. So we made these plasticizers out of waste PET, for example. Then, and I try to here make this kind of a comparison to building blocks. So basically polymers are made of many, let's say, things, and then with different chemical recycling, you can modify their how they look, what they can do and stuff. So then we try to make thermoplastic composites from waste. And here what we did, we used the recycled, or sometimes also percentage of virgin plastic often needed. What Tina also mentioned, it's not always easy to have only recycled 100%. Yes, in the lab, but in a real life, sometimes it's not, there are challenges. So basically we tried to use recycled polymers. We tested the many, like from PVC, PET and stuff. We added waste wood. So it was from the waste streams from the wood factory. So then we have this sawdust and wood flour that is anyway being discarded. So this is also kind of a push to try to use whatever you can from the waste, because in the circular economy that I will mention later, nothing is waste. Let's say we have to try to figure out the ways to use as much as possible everything from the industry, from everywhere. And then we had to add and test different additives. And then these are some examples. So again, some kind of an industry that they are making this, you see, this is kind of a wood, but basically it's it's composite made of a plastic and this waste wood and lots of additives. And in the end, it can look like artificial, let's say, plastic. In the end, these are some flooring tiles that I provided here as an example, and we tried to build it also in our lab. So basically it can be used in construction, in infrastructure, in automotive industry and stuff. So I just wanted to mention that when you make these composites out of waste plastic, you have to add fillers, and why to make different types of materials. So we tested lots of fillers are being put anyhow, calcium carbonate, glass fibers, sawdust, rubber particles, whatever. So we tried to make it from waste. So we added all those fillers from different waste streams to make it work, let's say. And also we tested lots of nano fillers. So these are actually these fillers, but in a nano form. Sometimes they help the structure of the future composites made from waste. And I wanted to mention, and also I think Tina mentioned in her presentation as well, and Anya, I'm sure now or earlier for sure, this linear to circular economy is having now this kind of a peak in the media and everywhere. We really, I think, need to do it. And sorry, this is in Serbian, I realized, but basically to make this let's say a circle. But I'm saying this recycling in the sense is very important, but we cannot only rely on that. This cannot solve us, give us this kind of a full circle. So I will maybe explain why. And also I want to show you a little bit more details about the circularity and about the technologies that exist now, that they can repurpose plastic waste into valuable materials. We have this mechanical recycling that we were mentioning, and then we have this purification we were mentioning, decomposition, if you remember these monomers and everything, this is here as well. And in the end, this conversion with lots of energy, let's say, use. So here in this, I also provided the link also about this report. It says that there is a clear momentum now for adopting and scaling up all these methods. So everything exists, but it's really not in this form as we need it to be in order to make this, let's say, circularity happening. I just wanted to show here this big file, let's say PET, polystyrene, polyethylene, these that we're mentioning in the previous slides. So basically here you can see the technological types that you can use on each of these materials. And here on the right-hand side, you can see what you can get as products from it. So from monomers to other polymers, liquid diesel or oil, naphtha, and different products from, let's say, waste streams by these technology types that we're mentioning. And in this report, if somebody is interested, they even provided a number of different industries that are actually doing it now. So but it's not, let's say, enough, but still there is, of course, lots of things happening. So this is also a good thing. It's not theoretical approach, so it is happening. So you have polypropylene, mixed plastics, electronics, and then there's these types of like thermal conversion, purification, chemical decomposition, or thermal decomposition that you can use and to get some outputs that can be used further on in the industry, in other industries, or for monomers or some other raw materials for different products. So basically, not to talk only about the technological aspects and all these challenges and stuff. And I wanted just to emphasize the social benefit component also, because they say with new jobs, you can even have 40% more jobs than with the jobs of disposing plastic in the, I don't know, burning it or in the landfills and stuff. And then, of course, this push is also pushing somehow the companies to innovate, to invest a bit in this field. So we have a new business culture creation with the push for like circularity and to have this our environment protected as much as possible. And then better living conditions are also social benefits. And now I was mentioning educational sector because that's where we are maybe today. So I believe that this raising awareness with the students and with among us and with the industries and everywhere is really important in better resource management and waste management and stuff, and also in building many innovative solutions. So when I say innovative solutions, really there are many ideas out there. So for all the students listening, if some of you is creative or want to look at more details, there's so many things that can be done out of waste. Of course, it's not easy to be commercialized, but there are lots of ideas. You can see the jacket, as you were mentioning, the nylon, but you can see also lots of, I don't know, furniture and I don't know, these 3D printing shapes, or I don't know, some kind of jewelry or handbags, or I don't know, different products or carpets, as it's also mentioned by Tina. So for students out there, look at the innovative ideas and contribute. So basically, as a conclusion, I just want to say recycling is okay, but only this circular economy leads to sustainable development. It means that materials can be recycled, of course, and I hope it will be in more, but also we have to rethink current models and also look about the design as much as possible. So the design products to be as much as possible in the life cycle, in the let's say in the living phase, not the end of life phase. So we need to kind of figure out, and if it's made from different materials, how to be more simple so it's easy to recycle, or how reuse or repurpose. So these challenges that I was mentioning in recycling are due to degradation or contamination of the streams. And this recycling infrastructure is sometimes not profitable enough or not properly developed enough to collect, process, and let's say collect all the possible wastes. And of course, lots of things need to be done on different scales, and lots of investments are needed by the governments, by the investors, industry. And here, sometimes we often say this transformational technologies, if possible. So something to be more later on easier to work with it and to make it circular, not only deal with end of pipe solutions, so something that is existing now to try to put it back in the system, but also think ahead. And that's why this collaboration is needed as well. The director of ECONIL mentioned also without the collaboration, he would not succeed in such a good example that he provided. So basically, this is very much needed also for the markets, because you can make a great recycling plant, for instance, but if you don't have the market to sell it or someone that needs this product, it's also, let's say, needed in order for everyone to stay afloat and to be alive in this nowadays, right? So I was mentioning that this recycling is not solely a solution, but of course it needs to be done as much as possible. But this rethinking of current models is needed in terms of all the benefits, social, economic, environmental, that we will hopefully gain with it. And I just wanted to say, for all the young people maybe here behind the screens, plastic is the integral part of our daily life. It's true, it makes so many things easier, but we have to, each of us can also play a role, not only to rely on the governments or industries or someone else to solve the problem for us, but we need to work on refusing sometimes, or reducing use of plastic bags, bottles, packaging, and all these plastic materials, because we are now focused on plastic, but it goes for everything else, right? And contribute to recycling, but also reuse, and all these innovative ways how not to create waste, right? And I think all this raising awareness is good, and I think it has to be done in continuation, maybe even more. And all this push by every one of us is, I think, helping, I hope, this let's say industry and all these stakeholders, not only industry and all governments and all of us, to work on, to contribute in further reducing plastic emissions into environment, and to hopefully go towards circularity much more, and lots more is needed there. So that's why I just always want for the end to say refuse, reduce, reuse, repurpose, and in the end recycle, and yeah, so on. So this 5R principle, everyone knows about 3R, but then 4R, and now we have 5R. So I think it's good to keep in mind this refuse, reduce, reuse as well.